In the last video we have seen how a vector can be decomposed into 3-dimensional space in the 3-dimensional orthogonal coordinate system visually. Now we will try to understand that numerically. So how to decompose a vector or how to get a component of one vector in a particular direction. So as we know that a component can be obtained by doing a dot product of that vector and the unit vector along that particular direction. So what is the meaning of that? Say for example, if I want to get the component of this purple vector, that is the original vector, then let me first hide the components as we have drawn, then it will be easy to follow. So let us just hide these first. Yes. So we have this original vector, purple vector, as it is oriented in a general direction in the 3-dimensional space, and it is drawn from the origin up to any point P. Now how to get the component? So component is obtained by doing a dot product of this vector and the unit vector along the direction in which we are interested in getting the orthogonal component. So this is the x direction, so that means this vector p dotted with I, it will give you the component. So what will that be? It will be basically that vector. So let us show that here. So it is this one. Similarly, if we do a dot product of this vector in the y direction, and that means with the unit vector along the y direction, we will get a component in the y direction. So it will be that component, y component, and if we want to get z component, similarly we will do that. So it will be the z component. So how to get it? We will do it like this. We will do it like that. Okay. Now let us closely look how we have done the dot product. So you see that P was the original vector. Here you see the left panel, that is the algebra view panel. So here you see that P is the original vector, and here is a dot product between P and 1 0 0. 1 0 0 is the unit vector along the x direction. So 1 0 0, that is the unit vector along the x direction. So if we do this, then we will get the dot product, and as you know, the dot product is a scalar component, that means is a scalar. So Px is the magnitude only, so that is 5. As you see that vector is represented by its component. So 1 0 0 means 1 along the x direction, 0 along the y direction, and 0 along the z direction. So it is solely directed towards the x and having the magnitude 1, that is why it is called unit vector. So P dotted with 1 0 0. Actually in this version of the geometry, that is 3D calculator, and that is 6, version 6, it is not showing, but in the 3D calculator 5 we have drawn it and it was showing dot product. I will show you exactly how it is done. So how the dot product is actually done. So follow this at the bottom of this page. So simply we will write, say for example some vector, say for example any vector, say for example k, that is, so say any vector k, we can write k, say for example x we can write. So kx I am writing. So kx is equal to, how to write the dot? Simply we will write dot. After writing that, you can see that dot will have 2 arguments. Okay, vector, vector, that means 2 vectors are required for this dot product. So we will select that option, then vector 1 and vector 2. So initially vector 1 we will select as P. So this is simply P, and the next vector we will select as 1 0 0, that is the unit vector along the z direction, x direction. So it is 1 0 0, or we can write simply unit vector, unit vector. So there is another command, unit vector. unit vector and x axis. So that should also work. If it does not work, then we will simply, yes, that is working, you see. So it will appear. Okay. Now kx is a, you see that as k is a scalar, so it is only showing the value, but how to show the vector that is having the magnitude as k, then we have to basically go for writing the direction. So it will be therefore associated, you see that it the dot is vanished here. So that is why, that is what I was telling. So if I want to write the k vector, so say for example k vector, so it will be therefore k x multiplied with simple multiplication with unit vector option is coming, as you can see, unit vector. Now object, it will basically require the direction of the unit vector. So here I will give the command x axis. Okay. Now you see that here it will appear. Now let me first stop it. So let me first. Okay. So you see that is coming here. Okay. So let me give it a different, first let me yes, now you see that has come. So basically this is this, that is obtained by dot product, you see that this one, right. So you can just change the length etc. in the setting and you will get thicker one, so that you can clearly see, and also you can give some colors, different colors, so that you can clearly see. It will be red one, right. So I guess you have understood it. So how to write the dot product? So from the point of view of how to use the GeoGebra for doing the dot product. So you see that first you write dot, then within bracket, so there will be two vectors. One is the vector along which vector for which we want to get get the component, and then the unit vector, that means the direction along which we want to get the component. So two vectors are needed. Again we need the, if we want to get the vector component, again we need the unit vector along this direction. So what I want to say, that means this vector dotted with the unit vector along this, so that will give you the only component magnitude, and again if I multiply the unit vector along this direction, that will give you the vector of vector component of the purple vector along the x direction. So always it will be like that. Okay. So similarly for all these we have got the component. So as expected, you see that we started with 5, so it is basically having magnitude 5, right. Again let me show you, you see that it is basically having the value 606. There may be some issue here, it is not showing, but it will be 060 actually. Anyways, it is not showing here. Here you see, here you can see that it is 007, it is showing the full all components, but here it is showing 50, actually it is 500, 060 and 007 as it is expected. Okay. If you cannot follow the means matrix notation, then just simply understand that this is the component, the value of the component. So you see that this is the component. Similarly, in the similar way I have done it. So P, that means here this means that P dot 010, that means P dot j, that will give you the magnitude of the component. So, the first two, that means there is a dot. So, P dotted with j, 0 1 0 means j. Again I have written unit vector y axis, that means j, again j. So, that is the vector. So, first two things together, taken together, it is the magnitude, and multiplied with the unit vector, it is the vector. So, that V is a vector, U is a vector. So, U is this, V is this, and W is this, in the same way. So, P dotted with 0 0 1, that is the k unit vector k, and again unit vector z axis, that means the unit vector along the z axis. So, first two will give you the component, that is a scalar magnitude, and then the vector multiplied with that, it will give you the vector component. So, that way you can basically get the components. Okay, I guess you have understood it. Thank you for watching.